here now with you.
It's at 1:30.
I was at 1:30 now.
1:30 to 2.
I asked him why.
In this room?
Yeah.
Did all this.
Did it have it before the switch? Oh, okay, yeah. We had some last juggling. All right.
Excellent.
No, at 1:30. 1:30. And it's Jiping and Haney and Jasmine.
Sorry? Okay. Okay. Well, good morning, everybody. You'll have to excuse me a little bit. I'm just coming out from a deal of food. So, bring off it, then we have OpenSwitch we can hear about it, and also talking about a few days of working OpenSwitch and different OCP hardware. So, I can go. And also, we started during the last OCP. There, so, and the purpose of the project is that is we include the stack, the integration with all it's pretty much create as I can work serving. Most of the project so we have also have GitHub Zero all the code read only. We have the code review tools where it's in Gary. That means that you can go to a review page and all the development of the code is happening, all the changes going, all the comments is happening. You can actually contribute or look at the code. And one thing in this sense is also that we have your developer from different companies, and not only companies, also we have channel, there are challenges there about how to build an operating system. So this offers that your license. There's also we're using the use of the state-of-the-art code. We mentioned the use we're using those and as I mentioned, we intend to have those two on L2 interface. We also want to have we want to provide traditional CLI. We want to provide DevOps-oriented interfaces. So,
so it was working, and then we swapped it.
we also have web UI. So we're trying to bring a little bit of what works, the traditional networking work with the new DevOps integration. So we want to have all these different If you want to look at more details, also there's a link here where you can look at the in the detail that my friend Michael Sayatz did in last workshop in OCP. So there is a lot more technical detail there. I didn't want to go into too much detail. I just want to recap in case that you haven't used the project before or the maintenance. So today, we'll talk about what's the current status. We talked about this 4 months ago. And back in the day when we talked about it, we pretty much saying, well, this is not code that project. We just want to throw some code over the fence and say, hey, here's a project, you figure out how to use it. Instead, what we want to do with it is create a community. We want to put some code to processes, bring a community together that we can develop, right? So the project is still development. It's still not production ready. We're trying to we want that code released by the and we have been I think happy with the options by the so in the RC channels we have a very active interaction about the developers very active discussion. Very strong opinions, you know, it's working. So we're very we have there are that the project is baked by multiple companies. I will mention something in a minute. So the main developer behind it is HPE, as Carlos mentioned. I work for HPE, but we have other companies contributing to the code. We have individual contributors working in the code. So when we actually show this Linux code, we get individual contributors coming and saying, yes, I really like this, and they're very engaged in the community. They're contributing. They're fixing code. We're really happy with the adoption of the community so far. As I mentioned, also right now in the mailing list we have 400 plus people for it. We're seeing all kind of activity, universities, ACP vendors, OEM, individual contributors that are interested. Also have been working with other OCP projects and members in their different areas of expertise. For example, Broadcom, Fairfood, already contributed their contributions for these companies already. I've seen your contributors that I'm seeing out here. But we also have international partners and KVU sign up. So actually, we'll see about that. So the update on the hardware support. So one front will be for we make this public is that we only have support for one hardware platform, the OCP 5712 design platform, and maybe this is very limited. But part of the reason we open source and we release early, we are having a very complete solution is because we want the community feedback and we want feedback from all the developers. So that was a very good, very high limitation at the beginning. Today, this is the list of what is currently on process and this is the status of the hardware support. So obviously the 5712 was the initial target. They have the main vehicle development that we're using right now. So they have pretty good support. The main target that all core developers are using. Just inside HPE, I think we have probably 70 plus developers in the daily basis just working on this project, these platforms. The 6712, the initial code is already there. So if you go to our repos right now, the 6712 platform is there. It's getting stabilized. It's getting started. This is the 38 by 40 USSD hardware. The 7712 is the 100 gig Tomahawk-based platform. Also, at the time, this started in the hackathon right now. Well, actually, it's already finished. Well, targets the hackathon upstairs was to get up and running. OpenSwitch, we snapped it from Canonical in eventual start. So, but we're also starting development of this platform. Some code, some patches have been uploaded, but we're starting to work on it. You can also right now walk out there and we'll see that Cavium is showing OpenSwitch running the 75,000, which is an Explain-based platform. They are planning to contribute the code into our repos soon enough. We're already started the process with them, but walking there, they're showing already in the floor. Wedge, we have one member of my team start playing with the Wedge in his free time. So we have initial port for it also. We're upstreaming the patches to support. One of the interesting challenges with Wedge was to look at the adoption for the model of the BNC support. It's a little bit different from the other switches. So we're trying to still working to figure out that, but we already have code for it. So we're starting to upstream also to Wedge. All these are community based, so there are start to take shape. We also have from hackathon the alpha networks, a couple alpha network bugs that we're bringing also in the hackathon to see if we can play with it and put OpenSwitch into them. Actually, some of the community members, individual community members, they start working with them and they have patches they're cleaning up and they're uploading for support for these boxes as well. So we're just waiting for those. This is coming from an individual developer. And also Mellanox is showcasing as well on the floor today OCP hardware where the new OCP hardware they're showcasing OpenSwitch working in multiple boxes. So as you can see, the action, all these different ASIC vendors and OEMs are starting to get interest on platforms. So we're seeing more hardware support release getting added. Obviously, as I mentioned, this is not a stable solution that you can go and deploy and expect stability. We're working through it. And we'll be working next month to make improve documentation. The support is coming up pretty nicely. We're really happy with this advance. So, quickly, I want to mention two aspects if you're interested on how do I enable this, how do I enable a new ASIC in OpenSwitch, and just take a quick look at what it is. OpenSwitch, the OpenSwitch architecture, I'm not going to go into deep into this, but you can refer to the presentation I mentioned before from Michael Science a couple months ago. OpenSwitch is have a user space daemon that is responsible for the interaction with the ASIC. So actually I have a graphic for it here. To just give a quick. So if you look at this diagram, what we see here is that in the architecture of OpenSwitch, we have a central database, and the OPS switch daemon is code based on the OpenSwitch switch code. And we have this interface, and we create a specific user space plugin that provides the abstraction layer and adapts to the ASIC SDK. So that means that we don't require any specific API. We don't require to be strictly OpenSL or strictly SI. We can actually support both if the developer of the SDK provides the right interface for it. So when we announced, we are first starting what was OpenSL. So we worked with Broadcom and they helped us a lot to ship the first product. To have the first release of the OpenSwitch code. And right now, as you can see from the work with Mellanox and Cavium, they also have created their own abstraction layers. In particular, Mellanox is working in a site and as SAI layer for OpenSwitch. So this driver could be replaced. So going back to the previous slide, I was mentioning we have a backend for OpenSL. We also have a backend that we call the simulator backend. It's based on OpenSwitch, so it's a software data plane. One of the things that we use OpenSwitch is that we support a virtual switch, where we have virtual switching. It's used in container mode for automated regression testing, but we also can create a virtual machine appliance that we can use for training and interaction if you don't have the real hardware. And we also have Veracruz that start contributed and is already mainstream the P4 code. Thanks. So we have been working with Veracruz, and Veracruz contributed P4 code simulation as alternative to the OpenSwitch data plan. So this is a very nice contribution. It's already in the source code. It's still also in development. And as I mentioned, site plugin has been developed by Mellanox for integration with the hardware. So this code is also in the process of being contributed. So, Michael.
Just one addition, Cavium contributed their plugin as of 2 days ago. So
Sorry, and Cavium contributed their plugin as well. What I'm not sure is the Cavium plugin is the Cavium SDK.
it's on top of Cavium Open API.
Okay, it's in Cavium Open API. So one of the advantages with this approach is that the implementer of the SDK can take advantage of the native capabilities of the hardware of the ASIC, right? So it's not reduced to the common minimal denominator that platform needs, the other platform will support. So if your ASIC can do something, you can have this layer that is pretty flexible to take advantage of that in your architecture. So this is a pretty good advantage as well. So as you can see, we have been busy. There is a lot of work going here. There is a lot of contribution for other companies. The other ASIC side, the other part is how do you port this to a new platform. So that is a work in progress. Pretty much when you're porting to a new platform, you have to we have a set of daemons. There are the sensor daemons, temperature daemons, port daemons that are responsible for dealing with the platform sensors. And this is a lot of the work, for example, that the OpenAI Linux platform abstraction take care of, or the contribution for the ACPI from Cumulus as well. OpenSwitch we already have one implementation of based on YAML files. We have been driving discussions with with the OCP projects that are doing their own hardware abstractions for the platform to find ways to integrate. We haven't really break ground yet on how the integration is going to happen or if it's going to happen. Mostly because, as you can see, we're having really busy with a lot of stuff. But the door is open, we'll review it. And the current model also, as we start adding new hardware, we're starting to find things that we need to account for, maybe the architecture of the FPGA or how we handle the ports or the accuracy topology. So those are, as we start adding new platform, we're starting to tweak those details. So it's still a work in progress, but as we start moving and adding support for more platforms, we are hoping that we get a flexible layer. Also, adding support for OpenSwitch to any platform requires a Yocto layer. The build system of OpenSwitch is based on the Yocto build system to create the image. If you're not familiar with it, Yocto is a build system for building a distribution, so we create a single image. This is very useful as well. We have interest of, say, the OCP, for example, from companies that want to run using ARM processors or more PC processors. So this cross-compilation support that we have for the platform is pretty useful for this. But one of the advantages is that if you want to support a new platform, there's pretty good documentation about it. So there's pretty good documentation from the Yocto project, how you add a new platform, how you enable hardware. So it creates a known path how to enable your custom platform using. So this is pretty much the updates that we have for today. And just quickly, the project itself, we just want to touch on the points that we have interaction with the OCP projects. And if we have any, we're open now for questions or comments. We have to answer those if there's any.
Any questions?
There you go.
Hi, just a question about the user space. So you've got the user space open switch D, what it's called. Do you ship with a underlying Linux distro? Is that Yocto?
Yes. So Jocto is not a Linux distribution. It's a build system that allows you to build your custom Linux distribution. So you can think about it as a custom Linux distribution. However, the bulk of the job in a modern Linux distribution is done by the system D, which is taking over too much stuff, right? We also have discussions, for example, as part of we're having in the hackathon, Canonical is interested in taking the OpenSwitch demos and creating a snappy application for it. And that's the way that we design the software stack. The components are isolated. We have isolated make files. We actually have a pretty strict, as much as we can, orthogonality between the build system of the daemons and the cross-compilation build system, which it makes relatively straightforward to create Debian packages, for example. So we actually have a community member taking a look at it. He actually posted, if you go to our mailing list, you'll see he posted a GitHub repo where it's supporting our daemons to run on top of Debian, right? So,
So in theory, I could extend that further and run on my own version of RHEL 7 as well.
yes, yes, you could. Since we're trying to ship, so this is one of the discussions that we have when they start a project. We have people in data center that are saying, I'm standardized on Red Hat, so I want to put this in Red Hat, or I'm standardized on CentOS, or I'm standardized on Ubuntu. Right, so there's no solution that will make everybody happy. And what we care actually is that there is a lot of integration about the whole process to provide this native experience for traditional kernel engineer. For example, of all the supportability aspects of the image. What happens if you crash the image? How do you get the card down update? How do you troubleshoot it, right? So we're trying to create operating, not some, as I mentioned, not some code that you just throw and say, hey, this is a nice demo. No, we're trying to create code that you think is actually in production, right? And so how you debug all these and how you integrate is very go deep with the integration of the current system. So we feel like the current architecture we have used that integration pretty well. It also creates a developer environment that allows reproducible results, which is very important in the early stages. But doesn't rule out that when we reach certain maturity point, we can easily start making that run on top of Red Hat or Debian if there's any important. And certainly Canonical is interested on Snap.
Sorry, I have a quick question. So I know OpenSwitch, this is an operating system. So what's the long goal for you to support this OpenSwitch in those common available white box space?
If there's a question,
Basically, what's the workflow kind of requirement? So does it only come out as also optional way to put operating system? What's your long goal?
I don't really follow up. So you're saying that when all the boots up, right, we install OpenSwitch.
That's one way to load up the operating system. Because all particular servers, they do not rely on only, right?
Oh, okay. So what if we can support some platforms that are not only it? Yes. For example, the virtual machine is not only right? So the build system can be being just to be adapted. If you want to, for example, we actually have community requests for saying, hey, can I port this in some legacy box that doesn't have all this, right? So all the vendors are interested in doing that. So that's completely on the exercise one model is what we discussed for the purposes here because this is a concept that you can modify the build system, you can make it run in other platforms, other bootloaders, it has complete platform. There's no strong attachment to only, but only is our preferred environment for open work.
My question is on the common event of OpenSwitch is common platform. At some point, the applications on the temporary restriction, the infrastructure they were locating all of it. Is there something that can miss that you address that? How do you avoid reducing common structure?
So, for example, if you you can implement, so one of the things that we have been looking, for example, is a modular configuration for the system. Pretty much like the K-config environment currently, where you can go to a platform and you can enable certain features. So if you look at the kernel build system, you have an architectural layout undefined to tell you this architecture for certain elements. Like, for example, we have a new wave of programmable ASICs from Cavium, Berkeley, right? And they may have the capacity to, reshuffle, increase, or change the table matching sizes and runtime, right? Maybe legacy ASICs won't have that capability. So by having the OpenSwitch, the OPS switch key interface, being able to not be married to one specific API, you can implement actually the native API for every one of these ASICs. You can also use runtime compilation toggles in the code and enable certain features. So they give you this ability that you're not married to one specific API, right? And then you have to go through just that.
And they can answer that.
The last question there.
So the question is from
Or you just clarify.
yeah. So at the end of the day, we have big models in the database. That's what one is. Now, they're not going to limit the big models to this polynomial API. So basically, whatever is shared, whatever code base you can support, yes, it will just be driven by the same big model. But it will allow people to actually have to innovate with their ASIC. You have additional features. And yes, when you build the image, you will say, this is this specific ASIC, and then some features will just get out of the switch. The data models will get out of the schema. Everything will go out, and you'll get just the image for this. So we want these super set of features, and obviously we'll push everybody to do the same common data, common data models for what they can show.
Cool. Well, I think last question. This is last question.
So, in one of the slides that you had the OpenSwitch API from the SI API. Now, is there not a to go because ultimately at the end, what else is talking to the whole API? If there are two uniform APIs, what will be the second uniform?
So remember the architecture is based on central database, right? So it boils down to the schema, the independent interface for the since the POP subscribe mode, the independent interface for the daemons or the features talking to what the ASIC needs to do is the schema, right? So that's the couple of them, right? All the schema, as Michael was saying, if you disable a feature, you look for a feature, the schema column is required to make that feature work. Therefore, a waiver won't take effect, right? So that's it. You're having another layer of configuration. It's also part of the basic infrastructure or the basic architecture that we have to subscribe models. And then we have to go through.
Well, thank you very much. Thank you.
Thank you.
We're going an update. It's 12:01. I hope y'all filed y'all shifts because you're gonna have to like snap someone in the line to get some food. Coming back here hot, 12:30. Kicking off with
Yeah, come back after. We've got the Canonical, we've got Cumulus, Linux Networking is awesome. Facebook team is going to talk, so pictures is going around. So we'll see you all.
Really wonderful. How are you? Yeah, good.
I see you around.
Selfish.
Do you have a minute to catch up?
Yeah. Let's let me just turn this off here.